Now, the second model, we've got that differential equation. We're going to write that in partial fractions. So we need a fraction with an x and a fraction with a 9 minus 2x. If I put x is 0 in, after I've multiplied through by that denominator, I get 3 is equal to 9a. So a is a third. Put in x equals 9 over 2 in, and then the a bracket disappears. So I get b is 2/3. So there are my partial fractions. So then we're solving the differential equation. It looks like this. We're going to separate the variables, get the x on one side, t's on the other. So divide by that x times 9 minus 2x, and then just end up with 1 on the right hand side. Split it up into my partial fractions so I can integrate it. 1 over 3x is a third ln x. Some people write, got to be careful with this, some people think it's ln of 3x. If I differentiate ln of 3x, I just get 3 over 3x, which is just 1 over x. That's really because in a sort of, I can write ln 3x as ln 3 plus ln x, which is an ln 3 is just a number. So I'm really just differentiating ln x really. The other term is a third ln 9 minus 2x, and then I differentiate the right hand side, I get t, and put a constant on just the right hand side. Again, when t was 0, x was equal to 3, subbing those in, I get a third ln 3 minus a third ln 3, so they cancel out, and I get 0 is 0 plus c, so c is equal to 0. So it's my sort of general solution, but it wants it in the form x equals. So I've got to sort of rearrange it so it says x equals. Multiplying through by 3 first of all, and then using my log rules, get those x's together because I want to get rid of the ln's. So I'll get x over 9 minus 2x is e to the 3t. I want it to say x equals, so I'll multiply by that bracket, expand it out, and then get the x term on one side, and everything else on the other. Factor the x out, and divide, and I get that. And it wanted in that other form where just had one term with the e. So I divided the top and bottom by e to the 3t. I get what they asked for. Sort of different way in the Maya scheme. They've sort of flipped this line here. So flip this and then do e to the minus 3t. And then broke this up into 2 parts, so 9 over x minus 2, took the 2 over, and then flipped and multiplied by 9, which oh, nice. Find the long-term population of goats predicted by the second model. Well, as t goes towards infinity, e to the minus 3t goes to near and near to 0. So the x gets closer and closer to 9 over 2, so 4,500.